So I'm Lynda Messaoudene. I'm a researcher from Algeria, and the work that I will present today is about optimization and validation of new ultrasound-assisted extraction of phenolic compounds from celery. We have used an experimental design and UPLC. Celery is a culinary herb, aromatic and medicinal plant, and it is a good source of vitamins, nutrients, and a variety of phytochemicals, including phenolic compounds. Due to its richness in bioactive substances, it has many therapeutic effects. And the aim of this study is to identify the phenolic compounds from celery and to generate a new and efficient ultra-assisted extraction method for their extraction. For this, the fresh samples of celery were ground by the means of a kitchen mixer, then the resulting material was stored in closed bottles. After that, the extraction was carried out by using ultrasound apparatus according to the experimental design. We have used as solvent a mixture of methanol and water, and the concentration of methanol ranged between 16 to 60 to 100%. The second studied parameter is the temperature, and it ranged between 10 to 70 degrees. The third parameter is the liquid to solid ratio, which ranged between from 5 to 10 milliliters per gram. At the end of the extraction, the mixture was centrifugated and the supernatant was removed and stored and filtered prior to its injection in the UPLC system for quantification and identification of the phenolic compounds. In order to evaluate the effect of the extraction parameters and to optimize the condition for celery extraction using the ultrasound-assisted extraction, the response surface methodology was used in association with the Box-Behnken Design. In order to measure the precision of the generated method, the repeatability and the reproducibility were measured using the best conditions. Repeatability was determined by carrying out 9 extractions under the optimal conditions on the same day. However, reproducibility was calculated by carrying out extractions on 3 different days, 4 extractions per day. The kinetic study was carried out by the investigation of the recoveries from the same samples under the best conditions at different extraction times from 5 to 30 minutes. And the results were processed by using the statistical software Minita. As a result, when compared with standards, 2 phenolic compounds and 2 flavonoids were identified from celery. The phenolic acids were caffeic and para-coumaric acid, and the flavonoids were the luteolin and its glucoside derivative. The performance of the model was assessed by the lack of fit test and the R square, in addition to the relative standard deviation of the experimental and the predicted values. The p-value obtained for the lack of fit was about 0.2021, which is higher than the significant p-value, indicating that the lack of fit was not significant. The second parameter is the R square, and it's closer to 1. This indicates the existence of a good correlation between experimental and predicted values. And so this suggests that 86% of the predicted values are correct. And according to this result, we can say that the developed mathematical model can correctly predict the recoveries. Now, the effect of, when studying the effect of experimental, when studying the effect of experimental parameters on the recovery of phenolic compounds, we have found that methanol concentration was the single significant parameter affecting the recovery of the celery phenolic compounds, with a p-value which is lower than the significant value. We can see from the figure that the recovery increased proportionally with the methanol concentration, and the highest level was recorded by the methanol concentration of 100%. The second studied parameter is the sonication temperature. We have found that its impact is not highly significant. However, we can see that the recovery increased simultaneously with the temperature increase, and the best recovery was obtained when temperature reached 70 degrees. Now the third parameter, which is the liquid to solid ratio, its impact on the celery phenolic compound recovery was found to be negligible, and after optimization, the best recovery was 8.33 milliliter per gram. Concerning the extraction kinetic, we have studied the effect of sonication time on celery phenolics recovery, and we have noticed that an increase in the sonication time enhanced the recovery initially up to peak value at 10 minutes. Then, as it is shown in the figure, an extraction time above 10 minutes led to a decrease in phenolic compound recovery because of the degradation by hydrolysis and oxidation at higher temperatures, especially when extracted for a long time. Concerning the method validation, the relative standard deviation values obtained for both repeatability and reproducibility were below the acceptable limits, indicating that the developed method is able to generate the same result for several experiments using the same sample. In conclusion, the best extraction conditions were 10 minutes for extraction time, 70 degrees for incubation temperature, 100% for methanol concentration, and 8.33 milliliter per gram for liquid to solid ratio. And the mathematical model is appropriate for the prediction of the considered response, which is the celery phenolic compounds recovery. And finally, the developed method was validated by the repeatability and the reproducibility, and it can potentially be applied in the pharmaceutical and food industries for quality control analysis. And thank you for your attention.